Kia ora whānau. This video is about conditional probability and risk. If you haven't watched the previous episode, then I suggest you watch that episode before you watch or pay attention to the details in this episode itself. The scenario we're going to be using is student results for the beep test, which is just a fitness test. So this is the same example from the previous episode. So if you've seen that video, then this should be quite familiar to you. Alright, here's a question. If the student is male, find the probability he scored below 11. The word if is important here. We can rewrite the sentence and say, given that a student is male, find the probability he scored below 11. The important word here is given. Now these two sentences are asking for exactly the same thing, so you're going to get questions which are one or the other here. So we just got to be careful of our words. Now, let's actually find the information that we need. Okay, there we go. So I've highlighted if and given that, just so you realize that those are the important words. And we're looking at males. We're not concerned about females, just males. So I've kind of blocked off that part of the table for you. And there's the total males that took the beep test, and here is the total number of males who scored below 11 in the beep test. So in terms of what we're going to calculate, we're going to calculate the probability of a score below 11 if the student is male. So again, we're looking at that 80 out of the 90 for all the males in this group. Or we could rewrite it as probability of below 11 given that the student is male. So that vertical line you see in the middle there, just underneath the or, that means given that. So again, these two statements mean the same thing, just like the two sentences above mean the same thing as well. So let's go through the calculation. So that equals, the total was 90, so that's the total number of people in the group, and we're looking at 80 as the number of males who scored below 11. So your probability is going to be 80 divided by 90, which gives us 0.8889 to 4 significant figures. Alright, so that's it for that part. Yeah, if that doesn't make sense to you, then I suggest you go back to the last video and maybe the video before that and revise your ideas of probability. But if you're happy with this, let's carry on now. Okay. So we're going to ask another question. This time, if the student scored below 11, find the probability the student is male. Or, given that a student scored below 11, find the probability the student is male. Now, these two sentences may look similar to what we did on the previous slide. However, subtle differences. So now we're looking at 11 or below only. So below 11, and I've blocked out that part of the table for us. Okay, so the total number of students who scored below 11 is 131, and the total number of males who scored below 11 is 80. So in terms of the calculation, here we go. The probability of male, given that, the probability of the student being male, given that the student scored below 11 in the beep test. So in terms of the calculation here, there we go, that's the total, 131, and 80 males scored below 11. So 80 divided by 131 will give us 0.6107. And that's also to 4 significant figures. Alright, so that is conditional probability. If you understood this example and the previous example, then you're on your way to success. So we're going to move on to the next part, which is relative risk. So relative risk and the magic ratio. So we're going to mainly focus on what relative risk is and how to use the magic ratio to calculate the relative risk. Okay, so please keep in mind these important points here. The first important point is that relative risk is not a probability. So it can take any number. So in particular, remember, a probability cannot be more than 1. However, relative risk could be any number below 1 or even above 1. What we are doing is we are comparing two events. So we're comparing two probabilities, essentially. That's where the word relative comes from. So here's an example of a sentence which you may have seen before, but explains relative risk. It is 3 times more likely a child will die while swimming in the sea compared with a public pool. Now, in terms of the relative risk calculation here, the number that's important to us is 3. So someone's gone and calculated the relative risk, and the answers come out as 3. So in terms of how this works, we're going to use the magic ratio. So the magic ratio is the probability of an event, so let's call that probability A, and we're going to take it to the ratio of a probability of B. Okay, so that's your ratio of probability of A to probability of B. Now, where it becomes magic is this part here. Oh, sorry about that. We are going to write the ratio like this. So on the left-hand side, probability of A divided by probability of B. So the first probability divided by the second probability to the ratio of 1. Now that is your magic ratio. So please keep that in mind. And what we're going to do is we're going to go through an example. Alright, so here is the table. On the top right here you see the table from the previous examples. On the top left, and on the bottom left you see the equivalent probabilities calculated from the table. So these probabilities were calculated in the previous episode. So if you want to go back and revise that, that's fine. You probably should do that before maybe you carry on. So what we're going to do is calculate the relative risk of a female scoring 11 or more in the fitness test, and we're going to compare that with a male. So these are the sort of high-end athletes amongst the students. So we're concerned more about the 10 and the 13 here. Alright, so the probability of A is going to be, well, the first probability that we want is, we're concerned with the females first. Okay, so we're looking at 11 or more female, 11 or more on the beep test, given that they are female. And in terms of the calculation here, okay, we've got the females, and that's the females, the portion of the table which applies to females. We've got 64 in total, and 13 scored 11 or more. So in terms of the probability of A occurring, it's going to be 13 divided by 64, which is 0.2031. Okay, so that's the females, but remember we want to compare that with the similar probability, but for males. So let's have a look at the second probability. I'm going to call that probability B. And the calculation is going to be, let's find the probability of 11 or more, a score of 11 or more, if the student is male, or given that the student is male. So let's have a look here. So there's your males. That's the highlighted part of the table which we are concerned about. We've got 90 males in total, and 10 scored 11 or more. Now, going back to the calculation, it's going to be 10 divided by 90, which equals to 0.111. Now, these two probabilities are rounded to 4 significant figures. So let's press on and calculate the relative risk. Alright, so there's our magic ratio. And what we're going to do with that is we are going to replace probability of A and probability of B, so two probabilities with the numbers that we found in the last slide. Oops, sorry, a bit too far there. So probability of A is 0.2031 and probability of B is 0.1111. So in terms of our magic ratio here, let's take 0.2031 divided by 0.1111 to the ratio of 1. Okay, so our final answer is going to be 1.8 to 1. So you may ask, which one is our relative risk? Well, it's going to be the 1.8. So in terms of the explanation of what that number means, now let's quickly go through this. So females are 1.8 times more likely to score 11 or more compared with males. Okay, so females are 1.8 times more likely to score 11 or more compared with males. So there's a higher chance that females out of this group of students will score higher in the beep test on that higher end of the scale, so 11 or more, which is where the superior athletes are with males. So great, that's it guys. That's relative risk and conditional probability. Thank you for watching.